Alright, we're going to see if these three functions are linearly dependent or linearly independent. So pause the video and give this a try first. Alright, so now let's see. I have x plus 1 and then 3x and then x squared. And this is what we can do. You know, when we are dealing with three functions, it's not easy, right? But if you look at just two functions, it's much better, right? And to deal with two functions, all you have to do is ask yourself, are they constant multiple of each other? If you look at f1 and f2, they are not constant multiple of each other, right? And now, if you look at f2 and f3, are they constant multiple of each other? No. 3x and this is x squared. No, right? And now, if you look at f1 and f3, are they constant multiple of each other? No again. So, in this case, you can suspect, because we don't have any theorem to support any of what I just said, but I'm going to demonstrate with the following, with the tools that we have, all right? I'm going to go with showing you guys that these three functions are linearly independent, because these two are Li, these two are Li, and these two are also Li, right? And to show Li, I can use the Wronskian. So let me do that for you guys right here. So let me put down W with this F1, F2, and F3, which is going to be determinant of x plus 1, and then 3x, and then x squared. And then I'll go ahead, differentiate. This is 1, 0, 3, 0, x, 2x, and then 2. And then I'll copy down the first two columns. So we have x plus 1, 1, 0, and then 3x, 3, 0. And I do this, right? So this, subtract that. Anyways, let's see, this times that. I'll put this down, x plus 1 times 3 times 2. And then this times that. Good, it's just 0, so put on plus 0. And then this times that. Once again, just 0. That's great. And now I will subtract, right? I will subtract the whole thing right here, and inside is technically plus. So I will subtract this right here. And this, that. 3x times 1 times 2. And then next I have this, that, which is 0. And then this, that. Because of this 0, it's wonderful, right? So plus 0 again. Okay, let's see what do we have. This is 6. Distribute 6 in there. We have 6x. 6 times 1 is plus 6. That's great. And now we are talking about minus. This is 1 times 2 is 2, times 3 is 6. And that's the x term. And that's all we have, right? At the end, we see that 6x minus 6x, okay, they cancel. But we end up with this 6. Well, this, of course, is not 0. I can indicate that this is not always equal to 0. Therefore, it's good. Remember, if the Wronskian is not equal to 0, that's good, because I can draw a conclusion. This right here shows that these three functions are linearly independent. And it just depends how you want to write it. Maybe I'll say f1, f2, f3 are linearly independent. That's great.